one.
So I need to do this side by side.
Do you sign up for your classes, or is that tomorrow for you?
Well, I already signed up. I signed up for econ, the second one, and
Did you watch the exam review? I haven't watched it yet.
yeah, I did. I actually attended part of it.
Did you shine any light, or not really?
Not really. He suggested to watch all the videos and make sure that we understand what, especially trying to get the lattices and stuff like that. So
This thing is, I watch all the videos and I still don't.
Yeah, I know.
It's one thing. I've gone into plenty of ones that I've felt like I'm like, oh yeah, I don't really know what I'm, or I'm not very confident. What was frustrating is that I felt confident in what I did.
Yep. And he said that we did all good on the ANOVA thing.
There's other questions.
But the other questions, I think
So the symbol for true population portion that's the p hat, right? The middle one.
Oh, is it the P?
True population
portion.
The population hat, wasn't it, or is the portion the one without the hat?
I think. Well, my answer is the P. Hold on, let me go back to where's my lesson? I was reading it, and
we start with the point estimate of P. That's right. Okay, that's right. We were doing
P is the
P is the
population proportion.
Wait, true population proportion. Okay, so it's saying to find a confidence interval for one population proportion P, we follow the same pattern. Yep. Okay, you are correct, madam. Okay, so P it is for the next two questions. N equals 100, P equals 0.25, and P hat equals 0.1.
Yeah, that's what they called it, P hat.
Yeah, the requirements for constructing a confidence interval are satisfied. True or false?
Well, we need.
Is this the one with
the P hat plus Z confidence interval? You need to get the Z, and it was not given.
Right.
The Z star is not given, and we have the P hat, we have the P, and the N, the population. And so, in order for us to get the confidence interval, we need to have is it 95%, 90%, or 99%?
No, this is the one. Isn't it it's the N P hat is greater than or less than 10, or N1 minus P hat this is the one that you see my screen right here. I think this is what it's asking. Does this fall under those guidelines?
Oh.
So we need to plug that in. I'll pop open an Excel sheet real quick. So I'm making a new one for this portion of the class. So if we know what P is, we know what
the N is 100.
We know what N is. So in this case,
so 1 minus
P is 0.5. P hat is 0.1, and that's 100. First equation is
90.
equals n times p hat.
I got 90.
N times p hat? That's 10.
No, n
right?
times p hat. P hat is 1 is 0.9. Guess 1 minus 0.10.
Right. Yep, so both of those are, so then we're going to say, let's see.
Greater than
I'm going to do this.
10.
Let me do this real quick. Conditional formatting, highlight, greater than or equal to 10. I'll say if f6 is greater than or equal to 10. How do I do that? Oh, I don't want it. Duh. Conditional formatting. Just 1 second. I'm just making a little.
Yeah, that's fine.
Making a little Excel deal for this to make it easy. Okay, so those are both good. Okay. Okay, so that was easy. So the true here, the requirements for conducting a hypothesis test are satisfied. So where are those requirements?
So those are true, isn't it?
So what's our
confidence interval? What happened to my link?
We can test this question using a hypothesis test. If the following conditions are satisfied, if NP is this.
Are you there?
So is it the same conditions that the other one was? Is it still the NP?
The NP.
And then is that the same height? Because on this, if you see this as we can test this question using a hypothesis test. Or is it
PTC?
Or is it, like, I just want to double check what the requirements are.
Hold on, let me check. Oh, come on. It kept kicking me out. So the empirical resources portion. A value of 70. What is 70? The PTC. What is PTC stands for again?
They're saying we can use the data analysis. There's a data analysis Excel sheet.
So confidence interval requires both greater than 10. So if it is greater than 10, the same thing with hypothesis test requirements. Both intervals should be
Yeah, no, it's
greater
still,
than.
so it's the same thing, I guess, right? So right, can you see my screen?
Yeah.
So right here it says, is the two requirements required to conduct a hypothesis test for one portion are that same thing, the NP, and so that's another true.
Yeah.
Okay. The study of first-degree murder trials was conducted in the state. A random sample of 60 people on trial for the first-degree murder was taken. These 45 defendants were found guilty. Find the p-hat.
So our N is 60, right?
Yep.
And X is 45. So our p-hat is 0.75. If I got it, the N is right. 60. So 0.750.
Yep. Create a 95% confidence interval.
That's what I'm trying to calculate. What's my P again?
Put your answers to margin of error, lower bound and upper bound. So they show lower bound 0.640 and 0.860. Wait, the margin of error. We need the margin of error. This is another one where they don't give us the margin of error. We have to do it real quick. I hate that.
Yeah, it's that the M is equals to Z star square root of P times 1 minus P over the N. And what's our P?
So I got 0.110.
How did you get that one?
Well, they have the confidence interval on the z-test. So they have the lower and the upper bound, and then you do the, add them together, divide by 2 to find what's in the middle, and then subtract the bigger one from that. Does that make sense? Like, I'll put it on my screen.
Okay.
This is how I do it. If I can get the Excel sheet to come over. I'm on Excel. Move.
You need to put 0 in front of your point.
No, do I? Oh, you know what? I'm in full screen. That's why. Hold on. So I do, so it gives me the lower bound and the upper bound. So I add them together and divide by 2. So that gives me, what's in the middle of them, right?
Mm-hmm.
This minus this
Okay.
is 110. That's how I get it.
Oh, okay.
So then the lower bound is 0.640.
Okay.
And the upper bound is 0.860. If you increase the sample size from 60 to 80, what do you expect to happen with the width of the confidence interval? So the bigger the sample size, confidence interval. I guess we can just look real quick on Excel. Huh? So we went and said. Shrinks, but that's looks like it goes down. That's the margin.
What's your confidence of interval? What level of confidence did you put in?
It was 95%.
equal to or greater than?
I don't know if I changed that. Hold on. I'll set the greater than. I don't think that, does that change though?
Oh, no, it does not.
I don't think that changes what we're doing. But so
No,
it's
it doesn't.
so it's asking if you increase the sample size, what happens to the width of the confidence interval? I'm not
So
sure.
it becomes 454 and 671. So it got smaller. Hold on. 0.860 less 0.671. It got smaller a little bit.
As you increase the sample size, the sampling error decreases and intervals become narrower.
Mm-hmm. Yeah.
So it'd be decreased.
So it decreases.
Yeah.
It decreased a little bit, but not much.
Yeah. To conduct the hypothesis test for one portion, two requirements must be met. Suppose P equals 1/2. What is the smallest n that can be to have both requirements met? Ooh, I can do that in my new little thing here over here. So if P equals 0.5, it'd be 100. Not changing. 100 times E.
Suppose that your P is 0.5. So
Well, 100 would get you the first one. Right? Well, no, because C3, hold on. What? They're saying P, but what? So what's? How do we get P hat from 0.5?
P hat is.
P hat is what's important in the confidence.
We got the P hat already. That is 75.
But this is, I think this is just a generic question, right?
Is it, or is still part of?
I don't think so.
They
Next
get
five.
11 and 12 are pretty similar.
No, this is a new question. This is not any. This has nothing to do with what's above it. This is just its
Okay.
own question. It says what's the smallest n? But I thought the P hat was the one that's important, not P, or not entirely P, right? Because
Yeah.
if P hat is 0.5, then you need a lot less n. But if P hat is 0.1, then you need more. So what? Oh, I hate when they do that.
Hold on, let's see. It said, oh, I just closed my book. So P is, hold on just a sec. Suppose P is 0.5. And the question is, what is the smallest? Just a sec, I'm looking at statistics. So it's 0.5. A small n. Hold on. So series the n is to conduct a hypothesis test. Oh, hold on. Let me see. It's one of the video, I think. Hold on. It says the video earlier.
And the next question is the same thing, so we need to understand what the heck these are.
Yeah, just a sec. I think it says the requirements earlier in the video. Just a sec.
Okay.
Which part of the video that is?
Finally, with the script.
So it says here, before doing one proportion confidence interval, requirements to check. The sample is obtained from a simple random sample. The requirements of doing a confidence interval is n p hat is greater than 10. So you can assume that the distribution of p hat is normal. Descriptive statistics to use numerical sample proportion is p hat. Graphical, use the pie chart bar. Okay, anyway, come on. But it didn't say how if it's half. Requirements. That's the same one. This does not mean the probability of containing P. The interval captured it or did not. Equals to 0 or 1. A level of confidence describes the process of creating an interval that predicts the proportion P. Known, which is 0.5.
I mean, the p hat value is, x divided by n, but we don't know either of those things.
Yeah. So.
Well, we know n, but we don't know x, right? Because n is what we're putting in, but how do we know what x is? Can we get that from p somehow?
The p value? But it's not there.
Right? Because if x equals n, then the p value is 0. If x is half of n, then it's 0.001. That's not the simplest.
Right.
Trying to see if there's like an easy way to find what p is here. Which is not, no.
And n is z. Oh, n is equals to c star over the margin of error. Weird. So but if it's not referring to the same question above, then, oh, golly moly. The answer.
Remember, the estimator of P is P hat.
Mm-hmm.
P hat equals X over N. And is used for both confidence intervals and hypothesis tests. So would you just use 0.5 for P hat because it's an estimator?
That's because it's just like it says on the previous lesson.
Then this is what I would, then the answer would be, if it's 1/2, then the N would be 20.
Mm-hmm.
If it's 0.1, no, oh, wait, yeah, 0.1. 0.1, then it's 100.
Yeah.
I'm guessing.
We'll see.
I guess we'll figure it out, huh?
Uh-huh.
Okay. So the next
Did
6
Sam say
questions.
that he can't make it tonight?
What?
Did Sam say anything last time that he can't make it tonight?
No, not that I know of. The
Okay.
water quality rating, about 6% of the microinverters, the researchers, they collect new data, and this time N equals 80 and X equals 38.
Confidence
N equals 80, X equals 38.
and 5.
The conditions for the hypothesis testing are whatever. 80.
The N is 80.
P is 0.6.
38.
And P hat is 0.475, right?
That's
Yes, so they are met. I have 38 and 52.5, which are both over 10. If you want to review that, that's kind of what I had. Let me see if I can zoom that in. That's pretty small. It's kind of my little calculator I made, and if they're green, then they're good. Those match up with your numbers.
Yeah, let me see. 16, 18. Oh, hold on just a sec. Confidence interval is 38 and where did I go wrong here? Is that equal to?
So this is just my little calculator on finding out if it equals if it's over 0.10 or if it's over 10. So, and also on theirs, looks like that it's correct anyways. So
38, and I get 38 and 42.
either way, yeah, no, that's fine. That's just either way. That's over. Both are over 10, so we're good, right?
Yeah.
We want to say P is less than, right?
P is less than point.
Okay, so what is P? P hat is 0.475. The test statistic. Is that the Z? No.
That's the
The
oh
P.
yeah, this is the
So 0.011.
0.011.
No, it says what's the p-value for the test is right below it, so that's not right. What's the test statistic in this equation?
This is that.
It's not the z-score, is it?
The PO is the
So what's their test statistic here? Is it a Z test, Z value?
I think it is because it's always it's either the T, the Z on the test statistics.
It's got to be negative 2.282. 0.011. What's the decision for the test? Reject or fail to reject. So the p-value is 0.1, which is lower than the 0.5. And what do we do when it's lower again?
If it is lower, hold on, where's my?
I still just cannot wrap my
I cannot wrap my head on that one. Hold on, I have to go back to my cheat sheet. What happened to my?
So if it's greater than, we reject. So we fail to reject.
We failed to reject.
No, excuse me. When the p-value is more, we fail to reject, so we must reject on this one. So we do reject.
We do reject because it's.
You know what? I just thought of that. So I guess if the p-value is less, that means that there's not enough information to reject, or information to overrule it. And if there's more information, more p, then I guess that's maybe how I can remember that. So if the p-value is over, that means there's enough evidence to hold on. Let me see this. Anyways, whatever. Yeah, but it's reject. So what is the best following summary of the conclusion of the test? There's insufficient evidence.
There is.
To conclude that there is not discrete, there's sufficient evidence.
There is an insufficient. So we reject him. Hold on.
We reject, but there's enough evidence, right? So it's sufficient evidence that the area is not decreased.
That concluded the water quality in the area has decreased. Has not.
It's either B or C, right?
No, C is there is insufficient evidence.
That's what I'm saying. There's either sufficient evidence that it's not, or there's insufficient that it has. But I think it's B. Here, I'll submit and we'll go from there. See if we've answered a couple of these right or wrong. Nope. So I think that last one, I think must be C then, correct?
You want me to try it?
Yeah, try C.
Is that the only error, Ms.
Yep.
Okay.
Yep, that was the only one we got wrong.
Hold on. Why did I get 15 and 16 wrong?
15 and 16 were negative 2.82 and 0. Was that right, though? Was C right? On 18?
No. Wrong.
Oh,
C is not one.
So 18 is not C?
No.
Interesting.
I think it might be D. It's either A or D. So, why did I get that wrong?
But we know it hasn't decreased.
15 is the test statistics.
So 15, you can look at mine. 15 is negative 2.282.
You know what? I got it backwards.
Okay. And then 0.011, yeah.
Yeah, I got it reverse on the other.
Okay.
So let me see. Point number Number 6 is 0.750. Number 11 is 20. 12 is 100. 0.475.
So I guess that was right when we're doing those P equals, what's the N? I guess P and P hat need to be the same because you don't know what that is. So you just estimate it's the same.
So if it's unknown,
That's good to know for the test, I'm sure.
redo my width.
Let me know if that's not B.
Is that back? 0.750. 7 is 0.10. Number number
8%. Yikes. 60%.
11 is 20. It's 100. So 13 is 14. It's negative 2.282. The value is 0. Octanol. So I will do. So we did the B and C earlier, right?
Correct.
So I'll try B. Submit. Yes, I want to submit.
I'm recording right now. This is Wildwood 8.06.
Yes, correct.
Okay, so it's delta. D is in delta, right? Awesome. So have you given any thought to the group project?
For our project, so there's several things that we can do. Like we can do baseball, as you mentioned earlier this week, and then we can also get like pollen counts, because I have this where you can compare two cities.
You could do what was
and
that?
then you can get the pollen. Hold on, let's see.
Oh, pollen counts, you said?
Send this. Pollen counts
Okay.
for allergies and stuff. Let me send this link to you. You can compare to cities, whether is it during fall season or springtime. You can do whether the city is higher pollen counts or
Right.
not, you know.
Yeah.
And so when you go to the like history, and you can click on the little dots and you can see the same month for the past few years.
Okay, so we can download kind of raw data then.
Or you can just like November of 08, it's 3.8 in my area.
So what do we, I guess, what's our, so help
So
me
we need
understand.
to plan design the studies. So we need to ask question, what do we want to do?
Right, so that's the thing, is we need to ask a question and say, okay, who, was the most efficient baseball player in the month of September? That was, da 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 da. Or we could do something like that, what you're saying. So I guess, we need to come up with a good question that's measurable. Right.
So yeah, so it depends on what is our target of research.
Right.
Or how many children of 10 gets diabetes, early diabetes or whatever. Those are different kinds of things that you
That
can.
one would be tough. That one would be tough just to, where do you get the data for that? And that's what I guess I like about, baseball is like, you have access to, historical data for, over 100 years on pretty much everything, because they count everything. So I guess we could get creative with questions,
we can do
who are the top 10 most efficient hitters at night on Thursdays in the last 30 years. I mean, you can get really crazy and just pick a random thing. And that's what I think is kind of interesting about baseball, is you can really,
or who hit the home run for during the postseason, or
you can, but you can get kind of as simple or as crazy as you want. I mean, that's what's so neat about baseball, is why they're still coming up with stats and new stats, because there's still questions that can be asked in different ways,
Okay, so now we need to come up with the design of our study. So if we're going to use the baseball, because we can all access that on via what do you call it?
Yeah, Major League Baseball has some stuff, and there's also some other places to get it.
Yeah, just a sec.
Yep.
So should we? Yeah, we can just do the baseball one, because since we have all different kinds of question that we can throw in and still make hypothesis.
Yeah, so that's, I guess, what I need to read the question a little bit better, is just, what kind of question do we need, and what kind of study do we need to make? I mean, because there's, like you said, I mean, we can come up with an interesting baseball question and analyze and get the answers pretty simply actually, but is that really what he's looking for? Or is he looking for something a little bit more in depth?
Well, we can put together something, and then he will make a suggestion, or he said that he will kind of give us a feedback.
Right.
So where's my question for the project? Study design instruction. So we're going to be doing league baseball.
I'm trying to find, there's a place where I've seen some really interesting study kind of things, and I just wanted to like maybe show as an example.
Final project overview. Science study. So design the study. Come on. So final project, design the study. There's a Microsoft Word attached document.
Okay.
So list the names of your group members, each person listed, blah, blah, blah. And so main writer for the design study. Oh gosh. Just right below the group members will be the main writer for each step. Design study. There are 100 chips in every bag of Chips Ahoy. Based on the interest of the group, here is the list of the few example. So have you clicked on that link of if you go to the instruction, design study instruction.
Where's that? Is that in week 8 or is that on the? There it is, right there.
There you go. Click on that one, and then click on design the study.
Those are the same thing, those two? Oh, that's the, hold on.
That one downloads the document, yeah. So that's what I'm looking at right now. So we need to state our research question. You just hold on, David. You did not ask permission to turn on that. Sorry, our little guy just decided to. I'm gonna go play on our television. You didn't ask permission. You need to help so we can pack tonight. Doesn't matter. You need to help so we can leave on time tomorrow. Thank you. So, not so loud, honey.
So I guess they're really wanting us to ask a kind of an open-ended question and not like who has the best batting average. It'd be more like, you know,
so
do
can
players
we instead of just player?
Yeah, but I would say, but we can say like, you know, do players over 6'2" strike out more than players shorter than 6'2", or you know, so we can just, you know, I mean, so it's more of a question versus who has the most home runs. It's more like, you know, do left-handed batters hit more home runs than right-handed batters? So that's the, you know, or something like that.
Yeah. Or yeah. Okay.
Do you know? That's what I said. We can. I think that's the biggest thing is we need to pick a good question. You know, do pitchers who throw more off-speed pitches strike out more batters than those who throw less off-speed? You know, I mean, I guess, you know, that's where, you know, I say maybe we agree on the subject matter of baseball, and then maybe I can send a quick group email to have, and then we can talk about the answer or question. And if we can get a question by Friday, this is due Saturday, right? The initial thing?
I believe so. Did I post that on?
I think you said that. I just want to make sure. Let's just double check that.
Hold on. Design the study self-reporting quiz. Let me see. Lesson 17. Let me go 17.
Design the study self-reporting quiz is on the 18th.
He said this week. Let me double check. Where's my instruction? Hold on. So the science study due date number 3 of week 9.
We're in week 9.
And
There's a quiz on the 18th. That's way down the road.
due date number 3. Let me check my calendar here. Uh-oh, make sure the cat doesn't go out. We have Houdini sometimes. They like to just run into the garage door. Well, into the garage, and if the garage door is open, they're out.
IRB approval reminder. I think it has something to do with, let's see, let's go to week 9 overview.
So the due date is, due date number 3 is, I believe, Saturday. One.
Yeah, it should be. Yeah, homework and quizzes are always due on Saturday. So design the study. Yeah, it must be Saturday. So I'll send out a group email tonight, which is kind of a little bit of what we discussed, and make them say, hey, we got to have a final question agreed to by Friday, so we have time to type up that document and submit it.
Due date number 3 is Thursday.
Tomorrow?
Fourth due date is Saturday.
Yeah, it's Saturday because it says homework quizzes are also due date 3, and they're done on November 11th at 11 p.m.
Really? It says. Huh.
We don't have anything due tomorrow for math.
Okay.
Except we have our group quizzes. Group meeting quiz is due tomorrow, which is already did. But that's due date number 2, right? Group meeting and quiz is due date 2. No, so due date 3 is Saturday, 100%. So okay, so I'll send that out, and we'll get that.
That if they don't know how to click on that thing.
I can attach the Word document.
Yes. Thank you.
And then I'll just essentially say what we talked about baseball. I'll give a couple of my examples and just say, hey, we need to come up with a question and agree on something by Friday at the latest.
Yes. Even though I'll be on the road, I'll be working on my assignments while my husband is driving.
Sounds good. You're going somewhere fun?
Well, just I signed up for whatchamacallit, Time Out for Women in St. George a while back, and not knowing that there's a lot of things to do every time.
I have actually still never been to St. George, even though
we have friends there, so we constantly stop by when we attend conferences. So
nice.
Yeah. So
how far is St. George? How far is St. George from where you live?
5 to 6 hours. If my husband will be driving, he can get it 5 hours.
That's not too bad.
Yeah, because Vegas is about 3 to 3.5 hours.
Yeah, for me it's like 8.5 hours is probably why we've never been there.
Oh wow.
Yeah.
So, but St. George is a nice place. It gets so hot in the summer. So.
Yeah, I know my brother has gone there a couple times with his kids to go play in a baseball tournament in early spring because it's already warm down there. And
but there's a lot of good places to go there nearby. So yeah. Anyways,
all right. Well, I have some more homework to do tonight, so I need to hop off. But I will send that email out tonight. And thanks again. Appreciate you.
Thank you. You're welcome.
All right. Have a good one. Bye.
Bye.